right. Hello, everybody. So today I wanted to talk about this new concept of imaginary numbers or complex numbers, as they're called sometimes. When you have an imaginary number and a real number combined together, that's what we call a complex number. It's sort of combined with these two parts. One of the things that students often ask is just why? Like, why are we doing this? And what is it good for? And like, why do I have to do this? And what I want you to do is just sit back for a second and go along as we go through some of the simpler examples where you've run into new types of numbers. And I want to convince you that imaginary numbers and complex numbers are just one more new type of number. They're just one more extension of what the word number can mean. And it actually is sort of a natural extension that you're ready for at this point in your math. So I want you to think back when you were a little kid. And this actually also, if you go back historically, this is like a couple thousand years ago where math was. Math was just counting objects. So we have a lot of those silly word problems like if you've got 3 rocks in one hand and 5 rocks in another hand, how many rocks do you have total? And that's a really silly problem, 3 rocks plus 5 rocks, and you can calculate, okay, that just makes 8 rocks. If you've got 4 rocks in one hand and 7 rocks in another hand, then you've got ridiculously large hands. You also have 11 rocks because you can add them. From that sort of question, though, there comes a natural question, which is of taking away. And this is something that my toddler is actually working on right now. She's like, if she's got 5 stuffed animals in bed and she needs to take away 2 stuffed animals, how many are left over? We could model that with 5 minus 2 equals 3. Now, if I ask my toddler, though, if you've got 5 animals in bed and I need you to take away 8 animals, my toddler would say, you can't take away 8 animals. There's no answer to that question. And I'd say, well, you're right. You can't take away 8 animals. And at that point, at a toddler's level of understanding, that would be a no solution. 5 minus 8, no solution. Can't possibly do it. That was where you were at when you were younger too. And then as you got older, getting into middle school, maybe elementary school, depending on where you were at, you learned that, okay, 5 minus 8, you can think of that as -3. Does it make sense in terms of how many rocks you can hold in your hand? No. In that sense, it's kind of imaginary. Does it make sense in terms of how many stuffed animals you have in your bed? Doesn't make sense. But at the same way that we can do, say, 8 minus 5 is regular 3, we can say that 5 minus 8 is the opposite. It's -3. In fact, historically, there were some mathematicians who called negative numbers fake or negative numbers imaginary or unreal at the time that they came out. People thought of them as just as imaginary or illusory as what we call imaginary numbers today. I want you to think about another example. When you were younger, you were talking about, let's say you had 20 cookies and you wanted to make sure that you and 3 other friends, so 4 people, could each have the same number of cookies. So you did, okay, 20 divided by 4 is equal to 5. In other words, 4 goes into 20. We use that sort of language of something fitting into something else. How many times does 4 fit into 20? Well, if I asked you to do 20 divided by 7, at some point in your life, you probably said, well, 7 doesn't go into 21. 7 doesn't go into 20. It doesn't go into it evenly. 7 doesn't go into 20. But after a little while, we just sort of get used to doing 20 divided by 7 and just getting a nasty looking decimal or leaving your answer as a fraction like this. Or you could say it's 2 and 6 sevenths, or you could say it's about 2.86. When you're younger, you don't really think of 2.86 as a number. You're thinking of whole numbers. You even think about zero, maybe as a number, maybe as not a number. You start thinking of negatives as a number. Then you start thinking of fractions and decimals as a number. And that's just another extension of what the idea of number is. In a similar sort of way, as you start thinking about shapes that you can put things in, I can put 9 dots into a shape of a square. And that tells me that the square root of 9 is 3. because the square has 3 on each side. I could do the square root of 16. But what if I asked you to do the square root of 17? You can't put 17 dots into a square. However, if I go here and type in square root of 17, I get this number, 4.13. What does that really even mean? It doesn't make sense to talk about 4.123 dots on each side. So this sort of idea of a square root equaling a decimal, not equaling a whole number, it breaks away from what we originally thought of as the idea of the square root. It fills in the values in between the other squares in a nice smooth way, but it no longer really means dots that fit into a square. So I'm just trying to give you examples of times in your life, and actually if you go back through the history of mathematics, 0 wasn't a number until it was. Negatives weren't numbers until they were. Fractions, decimals, irrational numbers like the square root of 17, these were all controversial at different times, and it's okay to feel weird about whether or not they really count as numbers. Now we're just doing that one more time. For a long time, we said that there was no square root of a negative number. And the reason why there was no square root of a negative number is because if I did something like negative 1 squared, I got 1. And if I did positive 1 squared, I got 1. So there was nothing that squared to equal negative 1 until now. All we're doing is saying, let's make up a new number called I. Let's square it, and let's make that new number equal. Oops, I almost wrote the square root. Let's make that new number equal negative 1. So this is really just a continuation of what you've been doing over your whole life. Things that weren't numbers became numbers. And then after we accepted that they could be thought of as numbers, we said, what else can we do with them? So the first step is just sort of suspending your disbelief. Like if you're reading a fantasy story, be like, all right, maybe there is magic. What then? It's the same idea here. All right, I didn't think there could be numbers that squared to equal negatives. Now there aren't. Let's just imagine that they are. Okay? So in the next video, I'll talk about how we can represent these and some of the things that we can do with them.